Hello viewers, I am Kausalya. Today we are going to solve problems related with Norton's theorem. So here the problem is determine the voltage across 200 ohm resistor in the circuit by Norton's theorem. So here this is our given circuit diagram, and this circuit diagram has a voltage source and a current source, and this is our resistor 200 ohms across which we have to calculate our voltage, right? So here the first step is we have to find the short circuit current, because a Norton's equivalent circuit will always have a Norton's equivalent circuit will look like it will have a short circuit current source, and there is a parallel resistance known as Thevenin's resistance. Right, this is how the circuit will look. So our first step is we need to calculate our short circuit current. So here you see the 200 ohm resistor is just simply short circuited, right? We have to calculate the current that flows through this terminal AB, right? So here the thing is, you see, we are having a voltage source and a resistor in series. So we can easily calculate the current, right? So the value of current will be 10 divided by 50, which is equal to 0.2 amps. So here flows 0.2 amps, right? And here when you look at this part, here we are having a direct current source. So again this 1 amps current flows here, right? Since here we are having a short circuited path, this 0.2 amps as well as this 1 amps flows through this path, right? So therefore the current that flows through this terminal, okay, is nothing but 1 plus 0.2, that is 1.2 amps. This is nothing but our short circuit current, right? Now one part of the problem is over. The next thing is we have to calculate the Thevenin. So to calculate the Thevenin, we have to remove all the sources, okay? Either it may be a voltage source or it may be a current source, we have to remove it. So once you remove, what happened here is, so to find Thevenin, here the thing is, you see, the current source is removed, so it becomes an open circuit, and the voltage source here is removed, therefore it becomes a short circuit here, right? Now we have to calculate the Thevenin across this terminal AB. Since this is an open circuited path, no current will flow through this 20 amp, so only this 50 ohm will comes in role, right? Therefore the Thevenin is nothing but simply 50 ohm. So just make a note of it. The next step is, now we are going to draw the Norton's equivalent circuit. So as I already said, here we will be having a short circuit current, Thevenin, and finally there will be a load resistance. So here just draw the circuit as such. A short circuit current we have calculated, it is 1.2 amps, and Thevenin is 50 ohms, and RL, that is across the terminal AB we are having a 200 ohms resistance, right? So to calculate the load current, what is the formula? Total current into opposite resistance divided by total resistance, right? So here what is the total current? The total current is 1.2 amps into opposite resistance. We need to calculate the current that flows through this 200 ohm. So the resistance which is opposite to this 200 ohm is 50. So 50 divided by total resistance is 200 plus 50. So once you solve, we are ending up with the answer as 0.24 amps, right? Now the question is, we have to calculate the voltage across this 20 ohm resistor. Now we know the value of current, we know the value of resistance. So once you multiply both, then voltage across the resistor is nothing but it is equal to 48 volts, right? So this problem gets over here. We will move with the next one. Obtain the Norton's equivalent circuit at the terminals A and B for the network shown. So here this is the given network. Again we need to draw the Norton's equivalent circuit, okay, across this terminals AB. So in the previous problem there is some resistor which is present between the terminals, but here you see it is empty, right? So again we have to proceed in the normal way. whenever we are requested to draw the equivalent circuit, the first thing is we have to calculate the short circuit current. So to calculate the short circuit current, we have to short circuit the terminals. So here we have to short circuit AB, right? So this is how it looks like, right? Here I have short circuited this terminal. And you see, since here we are having loops, we are assuming loop currents, right? So here let this be your loop 1, let this be your loop 2, right? Here there is nothing. We are having a resistor and a short circuited path. So no need to consider this as a loop because current will always flow through the short circuited path, right? So here let the current flowing through this loop 1 be I1 and loop 2 be I2, right? By inspection method, as usual, we are going to frame matrices. So here in this case, you see the current I2, right? The current I2, it will flow like this. It will flow through AB and it will end like this, right? Because you see here we are having two paths, right? Once current reaches this junction, it will divide into two. Say yes or no, it will divide, right? So once it gets divided, the current will always select the least resistance path. So here in this path, there is no resistance, right? But whereas here we are having a 10 ohm resistance. Therefore, the current won't get divided into two. The entire current will flow like this. It will flow through this AB and it will again move back like this. Right. Therefore, the current flowing through this 10 ohm resistance is 0 since we are having a short circuit path here. Right. So, again by inspection method, when you frame matrices, you see this is your loop 1. Here we are having a voltage source of 100 volt. Again, we are moving from minus to plus. Therefore, plus 100 volt. Again, here in loop 2, we are moving like this way. Again, minus to plus. Therefore, it is plus 20. So here when you frame matrices, you see 100 volt and 20. Their currents are respectively I1 and I2. So I1, I2. And again when you look at this loop, 10 plus 1 that gives 11. And here when you look 10 plus 2, right? 10 plus 2. So that gives the value of 12 ohms here because no current flows through this. So no need to consider this 10 ohm, right? So once we frame the matrix, we need to calculate the short circuit current, right? So what is the short circuit current here? The short circuit current is nothing but I2 because I2 is the current that flows through this path, right? So the first thing is we are going to calculate del and then del 2. So del is nothing but determinant of the resistors. So here the answer is 32 and del 2 is you have to replace the second column by the respective voltage sources. So whose value is 1220. Now I2 is nothing but del 2 by del. So just substitute the values and here the final answer is 38.125 amps. So now we have calculated I2, right? Now the next thing is we have to calculate the Thevenin. So what is the first step to calculate Thevenin? We have to remove all the voltage sources, okay? Voltage and current sources if it is present in the circuit. So here we are having two voltage sources and those two voltage sources are removed and our circuit looks like this, right? To calculate Thevenin, we have to proceed from backwards, right? That is from this terminal. So when you look here, you see the current when it reaches this node, it gets divided into two. Right. Again, this current when it reaches this node, it gets divided into two. Right. So when the current gets divided, what does it mean? The resistors are parallelly connected. So first reduce these two resistors. So when you reduce, the final answer is 0.91 ohms. So therefore here the circuit is, you see this 10 ohm and this 2 ohm as such and these two resistors have reduced it to 0.91 ohm. Again when you look at this picture, you see these two resistors are in series. So just directly add and answer is 2.91 ohms. And now you see here we are having a 10 ohm and 2.91 is connected parallel to this 10 ohm. Right. Therefore, the total resistance is R1 into R2 divided by R1 plus R2. So, that gives the answer as 2.254 ohm. Right. Now, we have calculated the short circuit current as well as the Thevenin's resistance. So, drawing Norton's equivalent circuit is very easy, right? So this is your Norton's equivalent circuit, which has a short circuit current and a Thevenin's resistance which is connected parallel to it, right? So here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.